Lexicography. Our talk is called Citizen Linguists and Decolonial Lexicography, Co-Creative Dictionary Building in Grassroots Digital Language Documentation. I'm Ana Luisa Daño, and I'm here with my colleague, Greg Anderson. We're both from Living Tongues Institute for Endangered Languages, and I'm also affiliated with Université de Montréal in Canada. So Greg is going to introduce some of the background of our work.
Right. So yeah, thank you, Anna. Just a little bit about Living Tongues Institute. We're a globally focused nonprofit focused on language documentation, scientific language documentation, and also in supporting grassroots effort in language maintenance. We're going to talk today about an app that we've developed called the Living Dictionaries app, which allows for the free development of state-of-the-art digital lexicographic resources with the assistance or without the assistance of a linguist. So a little bit on why we created this tool. So anyone who has observed this will note, as Skutnab Kangas did in a variety of studies, that state-run language programs often serve as vectors of complete assimilation to the dominant language, and thus the abandonment of heritage ones. Whereas grassroots digital projects can serve as a counterbalance to such pressures and bring visibility to lesser-known languages. And it is definitely true that access to high quality digital resources is absolutely essential for language documentation in the modern age, as information is increasingly consumed and disseminated digitally, specifically through mobile platforms. So assisting communities in developing such accessible resources is a tangible contribution that we as linguists can make in response to the colonialist underpinnings of linguistics. So a variety of scholars from an anthropological perspective largely have rightly critiqued linguistics as being rooted in colonialist projects. I think Arrington, 2001, McConey, 2013, most recently Hudley et al., 2024. We believe that it's a moral imperative of the 21st century to address such colonialist legacies of our field, and thus for linguists to make possible decentralized and decolonial approaches to language documentation, language resource development, and linguistic analysis. Moreover, it is not simply enough to acknowledge and critique the colonialist underpinnings of the fields, as all of the scholars previously I mentioned have done, because if it's not tied to actual tangible action, such dialogue remains empty, self-defeating rhetoric. So, of course, documenting languages is not only important to the scientific field of linguistics, but also to speech communities who are urgently looking for tools to combat this language loss that their communities are facing. Moreover, relying on institutional actors, such as state-based, academic, or juridical ones, do not act in the interests of linguistic minorities. So relying on them to enforce linguistic human rights, for real and not just on paper, has largely proven to be ineffective, except for in a very few contexts where the government could and has helped revitalize languages, although generally it's also a grassroots effort that they're supporting. And largely the success stories exist in places where there's just one such minority language to promote. So you don't have a bunch of different voices clamoring for the same attention, so to speak. So this is the one context in which, we have seen some success, such as in, Wales, Ireland, New Zealand, and Hawaii. As such, grassroots efforts that combine technology, collaboration, and community stewardship do provide a meaningful path to combat language loss. And in this presentation, we're going to discuss the Living Dictionaries platform, which was engineered to straightforwardly create lexicographic materials between grassroots collaborators as well as scholars, but not necessarily engaging scholars as well, and all with the goal of creating accessible digital resources for all underrepresented and endangered languages.
So now I'll talk to you a little bit about our team and how the platform works. So our team is run by Greg and I on this talk today, and also Diego Cordova Nieto, who's based in Mexico, who's a web developer and a linguist, and also Jacob Bodoin, who's based in Taiwan and the US. And between the four of us, we plan the new features, we roll them out, we communicate with citizen linguists and linguists using the platform, and run trainings and manage the platform. So here's an example of the homepage for the Tanacross Living Dictionary. Tanacross is an endangered Athabascan language spoken by very few people, somewhere between 10 and 100 people at the moment, spoken in the interior of Alaska. And so here, as you can see on this screenshot, you can see there's a listening button for audio files. The head words and head phrases are in the language in bold, and then you have an English translation underneath. You also have tags, and you have a video button and photo upload. And the search bar is very powerful for searching within any of the data fields in the dictionary. So our platform is an online source available dictionary builder that serves a wide variety of underrepresented, endangered, indigenous, Creole, and diaspora languages around the world. And our goal is to provide communities with efficient online access to systematic language materials that benefit language learners as well as scholars. All languages and regional varieties are welcome on the platform. So Living Dictionary's platform, it differs from the other dictionary platforms that are out there in several ways. For example, it functions in any web browser on any device. So even though it's a web app, there's no software to download, and there's anytime there's an update that we make to the platform, it's visible instantly. And it was designed by our team who are linguists and web developers. And it's used by many professional linguists around the world. But since it's straightforward and easy to use and available in multiple interface languages, it's ideal for citizen linguists who might not necessarily have formal training in linguistics. To date, the platform houses dictionaries for over 400 languages, and it has a user interface in 14 languages. So it makes it available and useful in all parts of the world. For example, here the interface is still in English, but this is what the Olukumi Living Dictionary looks like. So Olukumi is an endangered Yoruboid language from Nigeria. And so we collaborated with Dr. Belenli Orokoyo, who has been documenting Olukumi for many years. And so this project was to create an Olukumi print dictionary and then the electronic counterpart with all the same content as the print dictionary. So that was very well received within the Olukumi community in Nigeria. And here's another example of the Living Dictionaries platform, but this time with the Chinese interface. So one of our Living Tongues interns is working on documenting the Shenzhen variety of Hakka. So Shenzhen is a city in southeastern China. And so we trained our intern to collect and record some data in Hakka. And it's represented here using the Chinese version of our interface, which is locally useful for her and her community. Here's an example of an entry. So this is from Birhor, actually. So Birhor is an endangered Munda language spoken in India. And it's a language that we've worked for many years at Living Tongues to document, and we've worked closely with the community. So this is an entry for a plant in the Birhor Living Dictionary. So the head word is actually represented in IPA, as well as the Devanagari script, which is right below. And that's the locally dominant script, one of many dominant scripts in India, but important for this community. Then it's followed by Hindi translation, 2 semantic domain tags, scientific name in Latin, and it contains an image, as well as an elaborate notes section where there's relevant information about the plant's use. And so this is one of the many plants that can be found in the Birhor Living Dictionary. And it was created in close collaboration between Living Tongues linguists and Birhor tribal community members in India. Here's some recent innovations from the past couple of years. So we've been really working hard to respond to community feedback that we get during our trainings and online Zoom webinars. A lot of the functionality that you see today on the platform was actually requested by people using the platform around the world. So we've developed geotagging and maps. So dictionary editors may now include coordinates and regions in their dictionary entries. And I'll show you some examples of all these things in a few moments. We also really improved our import functionality. So dictionary editors can now import from Flex, .csv spreadsheets and other formats. So that might interest some of you in the audience or tuning in now who have data sets in Flex and want to use the Living Dictionaries platform. We can definitely accommodate you and import it if you're interested. We've also been running many internships over the years. We've got international cohorts who've processed dozens of batches of lexical and audio data for import. So they're usually linguistic students from around the world who have collaborated with us, and it's been really awesome to work with them. We've also improved our export and print functionalities, so users can export to CSV spreadsheets and nicely designed PDF files so that they can print them and use them in their communities. Here's an example of an entry that's geotagged in the Kalinago Living Dictionary. So Kalinago is a moribund language spoken near St. Vincent and the Grenadines in the Caribbean. And so we have many examples in that Living Dictionary of place names that the community wants to preserve and celebrate. So here is an entry that contains several names for one of the Windward Islands, which is translated to "tail is her body" in the Kalinago language. And so you could see a little map where the place name is indicated on the map. And so we've been working a lot. We're still developing the map functionality this year as well, but it's exciting. Here are some of our lovely interns. That's the most recent cohort we had at the end of 2024. So we had linguistic students from all over the world joining us. They worked on tags, they worked on editing, they worked on finding mistakes in larger data sets. And sometimes we would pair them depending on what languages they spoke. We would help them, we would ask them for their help with reviewing translations, but usually they were working on data entry and looking at metadata and helping with a whole range of issues on the platform that we're always trying to improve. So we actually have a cohort coming up in July if you know any students who are interested in doing this type of work. Here's an example of the spreadsheet. So this was one of our interns who I mentioned who wanted to create a living dictionary for Hakka Shenzhen. And so this is what it looks like when we import straight from a spreadsheet to the platform. We provide a template, and then people are able to fill it out with their translations and different orthographies or different types of elements that they want to include in their dictionary. Especially for the representation of tones, that's a whole other topic that we won't get into too much today, but we do offer as much, many different data fields to help people represent different ways of writing their language. We also offer a lot of space for different scripts since there are often competing orthographies as well. And so I mentioned that we've been working on PDF exports for printing. So here's an example of what it looks like for Boom, which is Grassfield's Bantu language of Cameroon, with approximately 20,000 speakers. So our platform allows users to generate and print a professionally designed PDF of the dictionary directly within the browser. The number of columns, the font size, the data fields, and optional images or QR codes that link directly to the living dictionaries can be configured within this print view for each dictionary. And we also have many sorting filters that you see on the right-hand side. So you can actually generate and print smaller sections of the dictionary, depending if you're trying to produce certain types of lexical materials for pedagogical purposes. And some of the important work that we're doing this year on our roadmap. So we'll be working on offline mode. So we're testing this functionality with our dictionary teams around the world who are in low bandwidth regions. So many people have asked us for offline mode. And so we're working on that. We currently have text editing offline, but we don't have multimedia editing for audio and video or images offline yet. So we're working on that. We're also looking at the ability to add multiple audios and images and other files to entries. So we're expanding that right now. And some of you may have heard of another platform called the Intercontinental Dictionary Series. And so we've been working with the administration of that platform to import that data with the help of our interns from that series onto the living dictionaries. And I mentioned we have an internship coming up in July for anyone who's interested. Now I want to say a few words on remote collaboration. And I realize we only have a few minutes left, so I will be brief. So we've tried to make co-creation on the Living Dictionaries platform very smooth and easy. So our platform allows the initial dictionary editor to send an automated email invitation to colleagues and assistants who want to work on dictionaries. And then collaborators can join the project, they can add or edit content, record audio, and these tools and features really help facilitate collaboration and language exchange across generations as well. And here you see the amazing Garifuna Living Dictionary team in California who's been developing the Garifuna Living Dictionary, and they're doing an amazing job. We also work with other nonprofits and other groups around the world. So for example, the Jewish Languages Consortium for Endangered Jewish Languages, we've worked with them on quite a few projects. And we've helped linguists in Zimbabwe, for example, those working on Kalanga. We've had numerous meetings with them over the years to help develop the Kalanga Living Dictionary. Here I'll be brief on this section in the interest of time. But we also work directly with communities from the ground up to build these dictionaries in some cases. So we facilitate the projects for other people who are working with communities. But when we undertake dictionaries from the ground up, we usually go through these 5 general phases. We go through a planning and consultation phase, where we plan out the work that's going to be done for the dictionary and who's going to work on it and who's going to be in charge within the community, you know, whether it's a linguist or a citizen linguist or both. Then we usually, for this particular living dictionary that's being developed, Tengukan Dogon, there will be online remote digital training sessions in Bamako in Mali, where all the people working on the dictionary would get together in Bamako and then receive digital trainings from our staff. And then we would proceed to training them with the data collection and programming phase. So we would probably create some new features for them if they needed it. And then the whole team works on assessment and quality control. And then we would import the data and deploy any new features that would be important for that dictionary. And those features would also serve all the other dictionaries too. I'll hand it back over to Greg to talk about citizen
Great.
science.
No worries. Thank you. So basically, we tried to design this to be as easy as possible for people who were not linguists or maybe didn't have technical skills that a lot of trained scholars might have. And also, we've tried to eliminate the burden of colonial and capitalist frameworks such as bureaucracy or subscription models. So we just have as few roadblocks and as few problems set up inherently to stop this process of co-creation. And who is it that's creating this? Well, who we can go to the next slide, Anna. And we consider a crucial role in this process to belong to those we call citizen linguists. And so citizen linguists are understood here to be people who actively engage in their speech community, believe in safeguarding their native or heritage language and work towards transmitting it in the future. They're motivated to create accessible language resources that are tailored specifically to their community's needs. They often play many different roles, wear many hats in their community: documentarian, language activist, digital content creator, even while many of them have no formal training in linguistics. They may have an advanced degree in another academic field and simply see the value of protecting their language, whether they themselves are fluent speakers or not. You can go on to the next. They take on this task themselves, often uncompensated and with difficult circumstances that they have to in order to make their languages more widely known. And they're like other citizen scientists that we have in other domains, like people who are experts in local flora or fauna. They often serve as a bridge between different diverse groups of stakeholders and primarily help bring local knowledge forward, and also have a sense of personal pride and connection to the language and question. So we have found that such citizen linguists are great creators of grassroots driven language materials, and this is why we've basically developed this tool. And they also understand that long-term projects like language documentation often involve multiple stakeholders and collaboration.
And one such example is the Where citizen science team in Brazil. So Where is an endangered indigenous language from the Carib family. And so here in this photo, you might see, oh, these people are hanging out, just writing stuff down and working on their phones, but they're actually interviewing some of the remaining speakers of this language and recording directly to the platform using only their phones, which are connected to the internet using Starlink and solar powered batteries. And so they created their Wet'suwet'en Living Dictionary, which is public on our platform, and they've done an amazing job in leading it and working on everything from local fauna and flora and very interesting culinary topics, birds and everything. And the translations in this living dictionary are in TDO, which is also locally important, and Portuguese and English. So this is what the gallery view with the images in their dictionary looks like. So in summary, our website offers the insights and systematicity of linguistic science in a user-friendly context, free of cost to citizen linguists, with no institutional or other administrative roadblocks preventing access to this tool. It highlights and preserves essential ecological, social, and linguistic knowledge that lie at the foundation of cultural survival. All intellectual property rights associated with the dictionary data remain within the language community itself from which the data originates. And the code for our platform is also accessible online through our GitHub. The platform supports citizen science by providing STEM opportunities to community activists to document their own languages and help them gain access to technical guidance from our team of professional linguists, anthropologists, and web developers. Thank you so much for watching today. We appreciate it. And now we are open for questions.
Well, thank you so much, Anna and Gregory, for this wonderful presentation. So we have 8 minutes for questions.
Well, maybe I can start with a question. This is really cool. It's so wonderful to see the way that the dictionaries have developed over the years and so on. Could you talk a little bit about the archiving side of things? So, your mention of Starlink reminds us all that things are a little more fragile than they might have been a couple of months ago. And so could you talk about the longevity of the dictionaries beyond the site and the materials that that are accessible currently?
Yes, so we have, because of our export features, we really encourage our living dictionaries editors to download copies of their dictionary for use offline. And so those, in some cases for the dictionaries that we've worked on, we've downloaded the entire database and archived them with professional archives like Paradisec in Australia, and with ELAR, and we're working on several other deposits as well that contain the entire Corsal, yeah, exactly, with Corsal for South Asia. So with our export functionality, you can download all the audio, all the images and videos, and of course the spreadsheet that has all the data fields in columns. And so that provides, incidentally, our spreadsheet too, in some cases we've had people download the whole thing and then make a lot of changes and then want to re-import the whole entire database. So we've done that for quite a few communities as well. It offers the ease of remote collaboration where everyone could be editing online together at the same time. And then also if they're ready to archive or use it for another project, they can just download the same exact version of what they're working on.
So yeah, basically we've entered into agreements with various regional archives that focus on various parts of regional, and we always archive our own stuff there and assist insofar as we can and is realistic with the time, or encourage the language of the citizen scientists to do so the same. So AILA for Latin America, the ALMA for Africa, various ones that exist already, but Yeah, it'd be nice if there was a centralized thing that we could just do it once and one off with, but that so far, as far as I know, doesn't really exist. But yeah, so essentially we just have institutional relationships with these archives right now.
Yeah, and it's typically our grant-funded projects where we are sure, we have to, the grants usually stipulate we have to archive the entire dictionaries and everything. Also, I would note that because we also want to protect the data sovereignty of the people who are working on these dictionaries, that the export and printing mode is only available for the dictionary editors themselves. And it's not available to the public to download and print it all out unless they activate certain buttons that say, make print available for the public. Then the public can go and print the dictionary if they want to, but only if the dictionary team wants that.
And in general, that's true of, I should just say, of the whole platform of the dictionary. Dictionaries we encourage people insofar as is possible and appropriate culturally for people to have dictionaries be public. However, we do have a private mode as well. And so there are a number of communities who would like to avail themselves of this resource, but never want to actually share it with the public. And that's also acceptable as well. So we have that option as well for people.
Yes, and of the 400 or so languages that are on the platform right now, there's roughly about 200 or so that are public on the homepage, and the other 200 are private because they're either under construction or they want to stay private forever, and that's totally fine. No problem.
Right. Any other question?
Yeah, I have a question. What about the funding? Where do you get your funding for the platform and preserving, archiving the platform and things like that? So sustainability of this.
Well, that's an excellent question. So far, our funding is ad hoc. That is, we have yet to secure any specific lines of funding, but all of the fundraising that we do that's not for some other specific purpose for the last 10 years is largely funneled into this program. So because it reaches so many different communities globally, it's the one that has the most bang for the buck, if you will. And so we've been funneling a lot of the, that said, we've been trying to get funding from secure longer term funding, but as of yet, we haven't done that. But we do have a variety of donors and things that are aware of the functionality of this tool and see the vision and support it specifically. So it's essentially crowd funded and private funded at this point, but we're looking for larger, longer term funding. But yeah, I mean, that's an issue right now, but it's not preventative in any way at this point. We have sufficient funds to keep it, afloat for the foreseeable future.
Yeah, but we've been lucky through our annual fundraising campaign through Living Tongues. We've been able to raise enough money to make the platform survive. And one of the because we're not a brick and mortar organization, we're all remote. We also keep our costs for running the platform extremely low. We use all whether it's from AWS or Supabase now for our database. We use like the most low cost option for storage. And we stay really up to date on internet security and everything. And so the platform is operating on a shoestring budget. And we also we apply for grants every year for our different language projects. So if we have been able to develop any features for our specific language on a project that's grant funded, then whatever feature we make, we actually apply it to the whole platform and translate it into every interface language so that all the other languages can also benefit from what we developed for one specific language.
All right. Thank you, Anna and Gregory, for your wonderful presentations. We don't have much time for more questions, but since they are still on Zoom, you can send them a message or put it in the chat and they can address it from there. Thank you so much.
Thank you.
All right, so we'll take our next presentation, Multilingual MFA. Alessio, could you go ahead and share your screen?
Yes, let me do that right now.
Fantastic, thanks. So I'll start things and then hand over to Alessio before too long. And I just put a copy of the slides in the chat for the people on Zoom if you'd like to follow along as well. So today we're going to be talking about forced alignment on low resource and related languages. So just to start with, I want to start with a roadmap of the of what we're going to talk about. Alessio, can you switch the slide to the So today we're going to start with just a little bit of background for where we're at, because in the Computel session, as well as in the ICLDC in the larger conference, we've heard a number of different ways of relating text to audio materials, automatic speech recognition, for instance. So we'll situate ourselves within forced alignment and then talk about some of the work that we've been doing recently on trying to improve models for languages where there's not a whole lot of data. So languages which are chronically underserved by the sorts of models that we're looking at. Okay, so forced alignment is a set of items that associates transcripts with audio and video at the utterance, word, or segment level. So when we have audio and video, we can align them at many different levels of granularity. For linguistic research in phonetics, but also elsewhere, it's incredibly useful to have this material. So for phonetics, particularly at the utterance level, but for language documentation projects around talking dictionaries, for instance, or extracting individual words from earlier archival recordings, having larger level groups is also very helpful. Forced alignment requires a couple of different things. It requires, at minimum, an acoustic model and information about the mappings between the writing system and the phonemes of the spoken language. So, for example, a dictionary of words along with their phonemes or their pronunciation. Creating the G2P, the grapheme to phoneme mappings, is relatively straightforward. But acoustic model training is data hungry. We see substantial returns, at least traditionally, with very large data sets. And so the performance across languages across the world is very unequal. So on the one hand, we have languages like English with thousands and thousands of hours of data available to train very robust models that generalize very well to a wide variety of speakers and genres and so on. And on the other hand, we have the other 99.5% of languages in the world where that sort of material is much less available. So that then leads us to how we might want to increase performance, or might be able to increase performance for the 99.5% of languages in the world that don't have such large data sets. There are various methods. So for instance, just using a high resource model to start with. So for instance, adapting the grapheme to phoneme, or the translation of the writing system to use an English-based acoustic model, or we can adapt a high-resource model. So, for instance, adapt or fine-tune an English model to work with with a different language. Or we also have massively multilingual models, or less massively multilingual models, to work across languages as well. So here we ask whether we can usefully combine language data from different languages within the same family. And in our case, working with Indigenous Australian languages, we have a large number of languages with very similar phoneme inventories. And so we're asking whether combining data sets, low resource data sets from a large number of languages will help with model improvement. So this is a slightly different question from, for instance, the sort of things that Neisan and colleagues have been doing, where they've been adapting more similar phoneme inventory languages to lower resource languages. In this case, we're taking a large number of low resource language data sets and seeing if combining them results in better materials. Okay, so just to briefly situate us with Australian Indigenous languages, there are roughly 440 languages known, probably audio data for around a quarter of those languages, so a bit over 100, maybe slightly more than that, probably around 120. The phoneme inventories of Australian languages are relatively similar, with some exceptions in different parts of the continent. They tend to look like the inventory I've given here. 80% of of the languages of the country can be described with this sort of inventory with 3 or 4 variants. So whether the laminodental and laminopalatal consonants are phonemic or not, whether there's vowel length, and a couple of different other different changes as well. And as I mentioned, these languages are chronically underrepresented in computational work and also in multilingual data sets. So the Common Voice corpus, for instance, has no Australian languages at all. And so with that background, let's now ask whether we can take advantage of multilingual data sets to train better Forster-Liners for Australian languages. So given the phonemic similarity for the languages across the country, can we use that to our advantage to train more robust models? And so with that, I'm going to hand over to Alessio, who's going to tell you about what we did.
Thank you so much. Yeah, so to answer that question, we look at 5 different models. 3 of these models are basically an English trained model on over 3,000 hours of global data. So this is from 8 different varieties of English, and then fine-tuned to one of 2 different Australian data sets. And then we also compared 2 different models that are trained from scratch, again, on the same 2 Australian data sets. So the data sets are a Yidin data, which is monolingual, from around 30 minutes of data from one language. And then also the Big 5 data set, which is a combination of 5 different Australian languages, similar phonological inventories, but not necessarily from the same language families. And this is actually around 10 hours of data in total. We evaluate these 5 different models on 3 different testing settings. The first one is the Yidin scene setting. This is basically when we take the models and then evaluate them on data that they've seen before. Then we have the Yidin unseen setting, which is when the models are tested on the same language. So they've seen the language before, but it's data that they haven't seen yet. And then finally, the Kumberlang setting, which is a language that none of the models have seen. Here you can see the size of the data sets along with their origin. So it's not very evenly distributed, but overall we get around 10 hours of data for the Big 5 data set. To evaluate the models, we use 2 different methods. The first one's the most intuitive. It's just looking at how closely the manual alignments match with the MFA alignments. This allows us to sort of come up with an accuracy metric where we can see the distance in milliseconds between a manual alignment and the MFA's boundary for an alignment. We break it down by manner of articulation and place of articulation. In this talk, I won't go over place of articulation, but I have some slides in an appendix if you're curious about that. I'm mostly going to be focusing on manner of articulation. The second way we evaluate the models is by looking at the analyses that result from these alignments. To do this, we look at vowel formant plots. And the reason we do this is because ultimately, like Claire was saying, forced alignment is the first step in a longer phonetic analysis pipeline. So it's less about the actual alignments themselves, but more about the results that you can extract from these alignments. And I will also mention that human analyses vary. All of the manual alignments were made by one expert. It's not fair to call it a gold standard, though, because people will differ in where they put an exact boundary. So before that, the pipeline. Here's just an overview. There's a lot to look at here. But down here, we can see the data sets. They come from 6 different Australian languages. 5 of them are used during training. Yidin is split into Yidin scene, which is used during training and evaluation. And then Yidin unseen, which is only used during evaluation. These 4 languages in the bottom left here are all part of the Big 5 data set. And then once we have these 2 training data sets, we feed them into models to create 2 models that are trained from scratch on these data sets, and then 2 models which are fine-tuned from an English pre-trained model. We additionally keep an English pre-trained model with no further fine-tuning as a sort of baseline. Once we have these trained models, we run force alignment to get the aligned files on these 3 different testing settings. And from these aligned files, we compare them with a human annotation, human boundaries, to do 2 different evaluation methods. The first one is looking at the diffs, so the difference in milliseconds between the manual annotation and then the forced alignment. And then the vowel formant plots, which allow us to compare analyses. Okay, so let's start by looking at the first the first evaluation metric we're going to be looking at. So accuracy. There's 5 different rows here. Each row represents a different model, and each column represents a different testing setting. I zoomed in on one of the different plots here on the bottom left to try to give you to give you a visual about what each of these plots represents. So in this histogram, the frequency of the bar represents the amount of times that the difference between the manual annotation and the MFA alignment was within that range. So in this one on the bottom left here, you can see that the English model that's fine-tuned on the Big 5 dataset on the Yeading scene testing setting does really well. Most of the boundaries are within -5 to 5 milliseconds of the manual annotation. The tails represent the sort of spread, the standard deviation of the model's precision. And so we kind of hope for a compact graph around 0. So looking at the Yeading scene setting, we can see that all the models are centered around 0, which is great. It means that overall they have the same mean as the human annotations. But we see a lot more spread for these two models on the bottom that are trained from scratch, which means that there's more variation in the boundaries that the forced aligner produces. We see pretty similar results for the Yeading unseen setting. And for the Kumbarlang unseen, we see that these models on the bottom right, the models that are trained from scratch, really do not perform well in this language that it hasn't seen. So now let's break it down by manner of articulation. So right now what we're seeing is a heat map where each row represents a different model and each column represents a different manner of articulation. The value in the cell is the mean difference between the manual annotation boundary and the MFA's boundary in milliseconds. Let's start by looking at this column on the right. This is just the mean absolute value, where if we see a value that's smaller, that's better. It means that there's less of a difference. And a larger value means that there's more of a difference between the MFA and the manual annotation. Comparing across the 5 models, we see that the best model is the English pre-trained model that's then fine-tuned on the multilingual dataset. And we also see that in only looking at the models that are trained from scratch, again, we see that multilingual datasets do show an improvement over monolingual datasets. However, if you look at the actual values, it's a difference of about 1 millisecond, so not that big. And even when only looking at the English fine-tuned models, which are the better ones, we see that the difference between the best and worst English fine-tuned models is less than 1 millisecond. So, a pretty small difference. We can also look at the different manners of articulation. So trails are pretty hard to place boundaries for. And in this situation, we see a large improvement from a multilingual training dataset. This is because it sees trails from a variety of different languages, and it's able to sort of generalize what a trail looks like a little bit better. Now what we're looking at is the same sort of heat map, same layout overall, but this time we're looking at the standard deviation, which represents the precision of these models. Again, we see the same trends generally, where the English fine-tuned models outperform the models trained from scratch in terms of precision, with multilingual models outperforming monolingual models overall. However, we no longer see the same trends for trills, although again, the differences between one row and another seem to be fairly small. Okay, so to summarize, in the Yeading scene setting, which again is when the models have seen the training data or the testing data during train time, we see that multilingual models show higher precision than monolingual models, by a little bit though, and that models trained from scratch are slightly less precise and less accurate than English-based models. Okay, let's move on and go through the other 2 testing settings a little bit faster. So the Yeading unseen testing setting, this is language that the models have seen, but the exact data they haven't seen. Looking at the column on the right, we actually see the opposite results. Where a monolingual dataset yields better results than a multilingual dataset. This occurs both for the models trained from scratch and the English fine-tuned models. So to summarize, we went over that real fast, but multilingual models show slightly lower precision than monolingual models, which is the opposite of what we saw before. And models trained from scratch are quite less precise and less accurate than English-based models. So the gap between these English fine-tuned models and the models trained from scratch is growing. Lastly, this is the Kumbarlang testing setting. This is when the models have not seen any data from this language in any capacity. In this situation, again, we see that multilingual models or models trained on multilingual data sets outperform monolingual models. In the models trained from scratch, this difference is quite big, both in terms of accuracy on the left here and precision on the right, with about 20 milliseconds of difference between the multilingual model trained from scratch and the monolingual model trained from scratch. As for the English-based models, the difference is smaller. All 3 English fine-tuned models perform pretty well, pretty similarly, but we do see an improvement here in terms of the model trained on a multilingual dataset, or fine-tuned on a multilingual dataset. Perfect. To summarize this testing setting, we see that multilingual models show more precision than monolingual models, and that models trained from scratch are much less precise and less accurate than English-based models. To go over all of the results with the plots we just saw, ultimately precision and accuracy are highly correlated, so I'm mostly focusing on precision here. Multilingual training data improved performance in 2 of the testing settings, which are the Yiding seen and Kumbarlang unseen testing settings, but slightly decreased performance in the Yiding unseen setting. And models trained from scratch consistently perform worse than the English-based models. So the biggest performance gap between the models trained from scratch and the fine-tuned models was in the Kumbarlang testing setting. You kind of see a medium difference in the Yiding unseen testing setting. Meanwhile, for Yiding seen, the difference between an English fine-tuned and a model trained from scratch was pretty small. Cool. Now we're going to be going over the second evaluation metric. This is basically extracting format values and then plotting them to see how much the analyses differ between models. So here we can see that the characters, the I, U, and A, represent the mean F1 and F2 score for the vowels extracted, while the axes represent the standard deviation. And the data was noisy, so you kind of see really big ellipses. This is more of a result of messy format extraction. The ellipses probably aren't this big in real life. The black circles and letters represent the human annotated analyses. The blue ones are the English fine-tuned models, and the red ones are the models trained from scratch. Here we can see that all of the analyses are actually pretty similar, with the exception of the model trained from scratch on just Yiding, which has this light red ellipse, which is pretty far off from all of the other ones. So the English fine-tuned models and the multilingual model trained from scratch all perform about the same. We see similar results for the Yiding unseen testing setting, although for long vowels, there's more variation. And finally, for the Kumbarlang setting, this mess of a plot here is actually pretty reasonable once we break it down. So I, U, and A all show pretty high performance for all models except the monolingual model trained from scratch. And the remaining 2 mid-vowels, E and O, show bad performance for both of the models because they never really had the opportunity to train on these phones. So E in particular is absent from all the training data, including all the languages in Big 5. Meanwhile, O, which we see that the monolingual Yiding model struggles with, is absent from almost all the languages. It's present but rare in one of the Big 5 languages. So we would expect to see lower performance with these tokens. So to summarize, in the Yiding seen and Yiding unseen settings, we see that all models except the model trained from scratch and only Yiding data gave approximately the same analyses, with multilingual models providing better analyses. In the Kumbarlang setting, the English-based models gave analyses that were almost the same to the manually annotated ones. But as we would expect, the models trained from scratch struggle with phones that were not in the training data. They would have no sort of reference for them, so this makes sense. Across all settings, though, again, we see that the English fine-tuned models outperform the models trained from scratch. However, in this case, it seemed like they had pretty similar performance with the multilingual model trained from scratch, while still outperforming the monolingual model trained from scratch. Cool, so the main takeaways. Which models worked best? Across the board, the English fine-tuned models work best. Even the off-the-shelf model with no further fine-tuning seemed to outperform both models trained from scratch in pretty much every way. However, in the Yiding seen setting, we saw that the models trained from scratch were almost as good as the English models. And this Yiding seen setting kind of has this privileged status because it's the most common one in fieldwork settings where a lot of the times, if you are working with a low resource language, the data that you have might be all the data that you'll ever going to get because there's few speakers or the speakers in an inaccessible location. So the Yiding seen setting is the one that ultimately I think is most realistic or common. Does multilingual training data improve MFA? And the answer is yes, although the improvements are pretty small. We saw slight improvements for English fine-tuned models, but larger improvements for models trained from scratch. And then ultimately, how do the analyses of these different models compare? We see that the English fine-tuned models are approximately the same as the models that had manual annotation. They were very similar. And they were also pretty similar to the multilingual model trained from scratch for tokens that it has trained extensively on. Yeah, so our recommendation is to use an English-based model. If you're able to adapt it to either a monolingual or multilingual data set that will yield better results, but the emphasis here is more on the fact that you should use a pre-trained model as opposed to training a model from scratch if you have less than 30 minutes of training data. Future work should focus on optimizing performance for these settings like the eating scene, because again, this is the one that most field workers are in. And there's a couple of ways to do this, but the most promising ones seem to be through hyperparameter tuning to encourage overfitting of these models, and through data augmentation to just have more data for these models to train on to begin with. Great, thank you so much.
All right, thank you, Alessio and Claire. We'll take questions now.
I have a question. How did you were saying it was comparable to manual annotation? What were the metrics? Was that like a precision recall? Manual annotation?
Sorry, you cut off at the end there. Can you repeat the second part of the question?
Sorry, could you talk more about comparing to the, what kind of metric did you use? Or how did you determine that it was about the same? For
Yeah, so for, are you talking about the first or second methodology? This one or the other one?
Sorry, I just remember your last slide. I can't remember which model it was that you said was similar to manual annotation.
Oh, yeah, so I'm talking probably this one. So when it comes to extracting the formants and then plotting them, you can see that the ellipses and the mean F1 and F2 values of all the vowels is about the same as the black one. So the black one is just a human going through all of these files, marking the boundaries for the phones, and then we use the same algorithm to extract the formants and plot them. So even if the exact boundaries differ quite a bit between the ones that an MFA placed and the ones that the human placed, when you extract the formants from the vowels and plot them, you get vowel formant charts that are about the same. So, so we see similarity in like a sample downstream task, even if the exact boundaries differ a little bit.
Thank you.
Thank you for the presentation. I'm wondering what's the boundary mean here, like the circle or the, yeah, so what does it mean?
You're talking about the ellipses here?
Yeah,
Yeah, so the axes of the ellipses, so basically the distance from the center here to the edge, represent the standard deviation in F1 and F2. So you can see here that, for example, for this, in the plot on the left, the E vowel, there was quite a lot of variation in the extracted F2 value, and that's why they're so spread out, like they're flat and horizontal. But there was not much variation in the extracted F1 value, and that's why they're pretty thin. So yeah, the location, the E is the mean, and then the size represents the standard deviation in F1 and F2.
okay, and how do you calculate the precision in your case?
Sorry, can you repeat that?
How do you calculate the precision? Like, so this is not a classification task?
Yeah, so for the precision, for these plots here, it was again with a standard deviation. We didn't use like any more advanced metrics for precision. We just wanted to plot both the accuracy represented by the difference in the mean difference between a manual annotation and an MFA annotation. And meanwhile, we look at the precision as a standard deviation of the same metric. So if there's a lot of variation, but ultimately they have the same mean, then that's going to show up as a very low value here, but a very high value here. And we can see that they're mostly correlated. You know, the more accurate a model is, the more precise it is too. But there was one instance where with trills, for example, some models are consistently off. And so that would show up as pretty high precision, but pretty low accuracy.
All right, so we have a question in the chat. So do you think it can be helpful to train false alignment on sound classes instead of specific sounds?
So this is a great question. And we actually did run an experiment on this, so stay tuned. Maybe Interspeech 2025 will be the year that you'll hear the answer. But the answer to this that we found was yes, but only to a certain extent. So we actually ran the same experiment pretty much using triphone classes, which allow you to specify different sets, like natural classes that the model can reason with. And we found that the extent to which you define the specificity of the classes makes a difference. So on average, these languages have around like 35-ish or 25 to 35-ish consonants. When we come up with sets of natural classes that had 22, like 22 was like the sweet spot, 22 different classes of sounds, we saw an increase in performance. Anything more specific or less specific actually decreased performance. So ultimately, yeah, it'll be helpful to train on specific sound classes to a certain extent. If you go too specific, well, then the model's not able to work anymore. And too broad, you get the results that we see here, which are good, but can be improved.
Just to add to this a little bit, so we're talking about increasing the size of data sets from 30 minutes or an hour to 10 hours. That's still not a large data set, of course, compared to the English data sets or the Tamil data sets that we've also experimented with, and so on too. So we are possibly getting towards the position where we could work with, maybe 50 hours rather than 10 hours, and then we might see more of the interplay between individual speakers or single speakers, but lots of data across different languages and so on too, because that's of course an underlying question for these sorts of things. If the phoneme sets are so similar for these languages, why are the models not transferable from language to language as well?
All right, thank you. Any other question? We still have a few minutes.
There's a comment from David Huggins-Daines in the chat as well that training on sound classes is something we did in one of the read-along studio papers. There's also a reference to prior work in that paper. Cool, thanks for that.
Sorry, I have another question. So based on a trained model, that's the F1, F2 frequency for a certain wall.
Sorry, could you repeat the question? It's kind of hard to hear.
So the question is based on a trained model. So how do you extract the F1 or F2 frequency for a certain wall?
Claire, did you hear that?
Sorry, I missed the very end. So we're comparing the F1, F2 frequencies for, how did we extract the data for that? Were you asking?
Yeah, how do we extract the data from the acoustic model?
Oh, okay, right. Yeah, so that's not part of the MFA. Once we have the Montreal Forced Alignment alignment model, once we have the aligned data, we can use PRAT or Parselmouth or other formant alignment, formant extraction techniques to do that. And Alessio, correct me if I'm wrong, but we've done this with PRAT, but we also used Parseltongue for this and got basically